All right, 7th and 8th graders, I'm going to start a video on the last section of chapter 14. And I'm going to share the screen and talk about it real quick. I'm just going to show the screen, and then there'll be some clues for the concept check assignment that you'll be having to do in your Google Classroom. So here we go. Let's share my screen and get started. All right, so chapter 4 is on chemical reactions. This section is on how we can control chemical reactions. So how does a reaction start? Well, in order for a chemical reaction to start, you need energy, and most of that energy comes from moving atoms, which is kinetic energy. And we've learned already that the higher the temperature, the more vibration, the more motion the atoms have. That's what causes it to be not move very much when it's a solid, because the atoms aren't moving very much. And you heat it up and it melts, and the atoms and the molecules slide around each other. And then when you heat it up even more, the atoms and molecules start flying off and becoming a part of a gas state. All right? So in order for the reaction to start, there needs to be energy, and that energy comes from the atoms, molecules moving around. Well, the atoms need to collide with each other. And so when they're moving around more, they collide more with each other. And they need to collide in the right position to break bonds and reconnect in different ways. So it's not just slamming into each other, but it's also hitting each other in the correct manner so that they can break bonds and reconnect in certain ways. And your answer to number 1 in your concept check is right into this area on this slide right here. Okay, so can you change the rate of speed of reaction? There's 3 important things that help a reaction to go faster or slower. And it all has to do with how many collisions of atoms there are. The first one is the temperature. We talked about that before. The higher the temperature, the more things are moving around, the more they kind of collide with each other, and the more collisions mean the more possible reactions. The other thing is the concentrations. The higher concentration you have of your reactants, the things you're wanting to react with each other, the more often those collisions will happen, and the more often those collisions will happen in the right way, and you'll get your reaction. You'll break some bonds, reconnect bonds, and things will happen faster. And the other thing is surface area. And what I mean by that is, if you have, the one thing that I've done before with kids, and you might want to try this at home if you have this, you have like an Alka-Seltzer, an antacid, or a fizzy, one of those tablets you drop in water. One experiment you can do that's really pretty interesting is when you drop that tablet, that Alka-Seltzer, that fizzy, into a glass of water and it bubbles, that reaction is happening. If you just drop that tablet in there, that reaction will go much slower than if you crush that tablet into a powder and drop it into the water. That reaction will go much faster because there's more opportunity for the 2 reactants to get together, the water and whatever fizzy or Alka-Seltzer there is, and it happens much faster. So surface area makes a difference. And you will find in many cases when people want to increase the rate of a reaction, they'll break things into smaller and smaller pieces, all right? A powder will react faster than chunks. All right, so in your concept check, answers 2, 3, and 4 is right in this section, and they're going to be asking you about multiple ways to increase or slow down reactions, and make sure you list more than 1. Probably you should list at least 3. All right, so how can you change the rate of speed? Through temperature, through concentrations of reactants, and through increasing the surface area or decreasing the surface area of the things that you're working on. Now let's talk a little bit about activation energy, because sometimes you can have all the right ingredients and you're not going to end up with a reaction. Sometimes you have to put some energy into a reaction. Even with an exothermic reaction, there's like a little lump or a hump. In your book, you'll see a graph where you have to bump up the energy before it starts giving off enough energy. And a good example is a fire. You can have the fuel, you can have the oxygen, you can have some heat, but no fire. And you've noticed this, you have to add energy, you have to add heat energy to get a fire started before you get heat energy out of it. And that's a good example of activation energy. And there's often an amount of activation energy that's required to get a reaction going especially an exothermic reaction, to get a reaction going before it will run on its own, where it will provide enough of the heat of its own to get the reaction going. All right, so that's activation energy. Also, there's something called a catalyst, and a catalyst is a substance that will help a reaction go faster, but it's not a part of the reactants. It doesn't change. It just bumps up the reaction speed. And you notice what I've written here. It says a catalyst will help arrange the atoms or molecules in the right way to help them react. And once the reaction occurs, the products leave and more reactants can get into place to react. This takes less energy than without the catalyst, and thus speeding up the reaction. Manufacturers will use catalysts all the time to get reactions that they want going faster. There's natural catalysts within your body, biological catalysts that help reactions that your body wants to have to get them going faster. This happens on the cellular level, so it's actually pretty cool stuff. This happens in a car. If you've ever heard in a car called something in the exhaust called a catalytic converter, catalytic converter tries to prevent some of the exhaust that comes out of your tailpipe from being bad for the environment. Carbon monoxide for one thing, and so it'll actually trap some of that carbon monoxide and then reconnect it with some other oxygen atoms to make carbon dioxide instead, which is much better for the environment. So there you are. Number 5 in your concept check will actually be a part or about these catalysts. And there you go. That's the quick review of section 3. Tomorrow we'll go over the notes and prepare you for the test. Hope you had a great day, guys. And we will see you tomorrow, I hope.